Is there any questions from homework stuff? Any questions from homework? Yes? It's what now, sorry?
I don't have the paper on.
You're good. So the homework sheet?
Yeah, it says like possibly due dates and then it's just like a range.
No. So again, the dates that are next to the things in the homework sheet are the dates we'll be lecturing on those. Okay. Homework, the soft due date is 2 days after I finish lecturing on something. So last time we finished lecturing 3-3. So 2 classes after that, this Thursday, you should be ready to turn in 3-3 homework. It's not late until the hard due date, which is the day of the test. Is everybody with me? So this is something for you to consider. You have to have a way for students to self-assess if they're on track. Okay, so especially for the older grades, you want them to be able to kind of self-assess, am I on track? The soft due date I give you about like 2 classes after I finish lecturing is a way to gauge, am I on track? So it's not the end of the world if you're not ready to turn 3-3 in. It's closer to the end of the world if you haven't even started chapter 3 homework yet, when 3-3 is kind of soft due to you. So you have a way to tell how far behind am I. You with me? And then the day of the test, hard due date. Yes? So say something else, but I completely forgot. Oh, you need your. Does anybody else not get their quiz back yet? Get the show off. That I go. What is it? Sylvia. Go ahead. Further just a bit. Make corrections. You're welcome.
How did this affect this?
Guys, do you guys remember, does anyone remember how your quiz grade can go up twice? Yep, do you know your quiz grade could go up twice? You guys know this. I almost wore my It's in the Syllabus shirt today, actually. You can get, if you do corrections to the quiz and give it to me, you can get points back from that. You guys with me? If you do corrections to a quiz and you get points back and you do better on the test, your quiz grade goes up again. You guys understand? Yes. So for example, if you get like a 40 on a quiz, right? You didn't sleep the night before, you haven't done the homework yet, and you're like, damn, I forgot we had a quiz. You sit down like, shit. You write shit. So you say you got a 40 because you got a couple things right. You with me? The test comes, you're ready, you're prepared. You do corrections to that. You get them all right. It goes up to a 55. And you're like, yay, slightly higher up. 15 points though, nothing to sneeze at. Then on the test, you're ready. You get an 82. That 55 becomes a freaking 82. You understand? Oh, but you have to do all the if you get half of the corrections right, and you get a higher test grade, I'll average you halfway. Does that make sense? You guys kind of with me? So you get half the corrections you could have, and you get a higher test grade, I'll average you halfway. So like if you get 1/4 of the points, I'll give you 1/4 of the way. Yes? Sounds exactly like some weird ass math dude would do with this spreadsheet book. Now, if none of that made sense, just make corrections. Have somebody check it, me or a tutor. How many of you guys have gone in and gotten help from a tutor? Anybody? Two people? Did it go okay? Yes? I like this. Not the best, maybe?
Well, no, I've been almost like every day. So sometimes they help and sometimes they don't.
And the weird thing is, the tutors should know. Sometimes the tutors don't feel. Not every tutor's taking 125, because who's only people that have to take 125?
There's only like 2 tutors and they
Exactly.
don't know how to do it.
Exactly.
Yeah.
Why is that true? Because where do we get our math tutors from? Math students. Math students don't have to take this class. You with me? So I think there's a total of 4 tutors, but they're obviously not all on the schedule at the same time. there's only like half an hour of time. Like, I think right now, there's no 125 tutor in there, like right now. And we don't care, because we're all right here. There's like from 6 to 6:30 on Wednesday or something, I can't remember that. They don't have a 125 tutor. Otherwise, they always have at least one 125 tutor. Do not hesitate if you go in and somebody comes over and you say, do you feel comfortable tutoring 125? I need help with 125. Because they should be like, no, I can do all this other shit, I can't do that. And then get the person that can help you. Are you guys with me? And again, not all math majors have to take this, right? Okay. So even though they could do it, I understand them feeling uncomfortable trying to jump into it in the middle of everything. If you do have a bad experience, though, please tell me, right? If you have a great experience, please tell me. That'd be good to know. Did everybody get the quiz back? Oh. Yeah, you got yours. Everybody else got there? All right, guys, anything from homework stuff? Any questions? Some of them questions are weird as shit, so I expect some kind of question. Yes?
I think it's different one.
21?
Yeah, different.
Oh, yeah. The star looking dude. I think. Let's see. Star looking dude. Star looking dude. Sorry. Oh, by the way, I did watch that damn movie. One was saying I watched that movie.
Oh, the long one?
Yeah, we were looking at each other at the end of it like.
It was good.
Yeah, it was good.
But it's like.
It's definitely Stephen King because he likes to build character, but he uses stereotypes, but it's in a way that I don't care. Huh?
What did you think about the ending?
That's what I'm saying. Was it a dream? Do you see how the crowd like disappeared? So you're like, is this real?
Like after the movie, I had to like reflect on it, and I was like, is this a dream or like did it not happen? That was crazy.
I don't know. I'm not sure what to think. Really messed me up though. I get into my movies, so I had a few tears at some points. I'm right. This one here, right? Okay. Oh my gosh. Oh my gosh. What is happening? Wait a minute. Nope, that didn't work. This is exciting. No, you just don't want to work. Well, that's not going to be good. It's going to be bad. All right, everybody, I'm sorry. Everybody just... Did you try to turn it on and turn it on? Turn it off, turn it on. Hey, all right. Hey, all right. Hey, all right. All right. So guys, this one here. It asks us, what's the magic of this triangle, right? Where this is section 3.1, so this is all about addition and subtraction. So I would probably guess that somehow things add up to certain things in certain places. You guys, I don't know if you guys are with me. So if I were you, I would just start trying to see, okay, for example, do you guys see a bunch of triangles in there? This might be the answer. I forgot the answer. But this might be the answer. Because the first thing I saw was a bunch of triangles. Yes? It isn't every number sitting on a triangle. Do you see what I mean? Now, in the middle, there's another shape in the middle. Yes? Does anyone? Let's not worry about that. So, this might be the damn answer, but oh well. What is 21 plus 22 plus 25? 20, 40, 68. Yes. What's 27 plus 19 plus 28? Good. It's not the answer. Okay. Anybody? You watch this, guys. If that was a 20, this would be a little easier, right? 20, 40, 60, 75, 7 and 8 is 15, right? This is one less, so it's 74, which is not the same thing we just got here, right? 24, 60. Yeah. Okay, but that's something to check. Do you guys see what I'm saying? So sometimes a student looks at this, doesn't even know what it wants you to do. There is something about this, these numbers, the way they're set up, that more than likely they all add the same if you look at them a certain way. Do you see, okay, this is probably the answer, I don't know. Do you see lines of numbers? Okay, all right, I don't know. That might be the answer, I don't know. So everybody kind of see what I'm saying? A lot of these magic shapes, a magic square is a square where if you add this way, that way, across, they all add to be the same. So most of these magic shapes is because you add, they all add to be the same. Does that help? I might have given the answer away, I don't know, but you still have to check. I don't blame you. When you read through that, you're like, I don't know what the magic is. What the hell? The magic is, I don't know. Anything else? Is that, hopefully that's okay. Who asked that question? Is that enough? Is that enough to go on? Okay. Anything else from homework stuff? Okay. We got through 3.3 last time. 3.3 we ended with like talking about PEMDAS and exponents and all kinds. And I think we did handout, we did some group work. Okay, that was last week. We're going to get into chapter 4 today, and I've kind of been getting you ready for chapter 4 in a way. This is the part that could be really frustrating for a teacher. And we're going to watch some videos today. We're going to watch some little people. I have finally figured out, I feel kind of dumb talking to you as a teacher, and you guys are future teachers. I did something that I'm like, why the shit did I never do this before? To get you guys hopefully a little more engaged in the videos, right? Because I understand a lot of us who are like, you guys are probably like, I don't know what to say about this. What do I say? That guy's tie is weird. I would take that, but you know, it's not really applicable still. All right, I'm sorry. You guys know, every time I watch these videos, you're all like, ooh, video, and then I dare to ask you to tell me something, right? Okay, we'll see if that helps. So, 4.1 is all about mental math, which sounds kind of weird. So you're like, what do I do in a section about mental math? What homework do I give you? You write down what you did in your head. You capture what you do for mental math, you write it down. So, we've already done things related to mental math. For example, if I had to do this problem here, can somebody help me figure out what's a good thing to apply here? Do you want to do 21 times 17 in your head? You want to do 13 times 20 in your head? You want to try the damn thing? No. So that there is a property in mathematics that will help you. So a lot of students understandably don't understand why we make a big deal out of commutative property, associative property, all these properties. It's because they directly relate to things we do to make math easy to do in our head. So what could I do? Does anyone see anything I could do? Do you see anything that's repeated? 21. What you got, Meg? That the observation you're gonna make? Do you know what to do because 21 is in both pieces? Sort of divide, but not really. What? Yes. So when I distribute something, doesn't each piece get that same thing? So can somebody tell me what number was distributed? Across what? What number was distributed? 21. Across what? 17 minus 13. And what's 17 minus 13? And what's 21 times 4? 2 times 4? 1 times 4? Now, here's the way I look at this. This is 17 21s minus 13 21s is 4 21s. But this is what distribution does. It actually kind of forces you to realize, oh, this is 17 stuff minus 13 stuff is 4 of the stuff. So you can kind of see it more directly. Okay, maybe. So distributive property actually helps us calculate things. It's not just some little thing we force you to do. Maybe. Is that okay? So anytime I see addition, subtraction, every piece has the same number in it. You can pull it out, and what's left is a lot easier. Maybe. So like, if I had 5 times 89 plus, what do you got, Jeff? 55. This is less explicit, but what number does both parts have? 5. So what do you get when you take a 5 out? What must have been here so you get this? 89. And what must have been here so you get this? 11. What's 89 plus 11? 100. Okay. I like it. That's a hell of a lot easier than freaking 5 times 89 and then you have 55. Yes? Maybe? So this is obviously what property? Just in reverse. What property is this in reverse? What would you do to get from here to here? Distribute. So this is distributive property in reverse, right? I call it undistributed property. If you're able to put stuff in, I'm able to take stuff out. Right? Math goes both ways. Be just. Okay. Something else we talked about. Anybody remember what this 3, Jeff? Really? 1 to 3. Oh, there is a 2. So you were right, Jeff. Yeah. What about? Yeah. How about this guy? Does anyone have a method I could use to make that really easy to do in my head? There's 2 main things I'm thinking about right now, but I'll accept anything. Does anyone have a way to make that easy to do in your head? Yes?
Take 20 out of the 29, add it to the 8.
Okay. So one method, we'll call it method A, is write the 29 is 20 plus 9. These together is relatively easy, right? That would be 107 plus 9 is 116. I heard you. It's all right. We'll move on past. Does anyone see a different way to do it? Now that's the way I didn't even think about doing it. Does anyone see a different way to do it? Using basically the same idea. Does anyone remember what that's called? She took 20 from the 29 and gave it to the 87. Compensation, yes. I like it. Compensation. Is there a smaller number I can take from one to the other to do compensation? What do you wish was there instead of 29? 30. I wish it was 30, yeah? Does everybody agree with me that if it was 30, this would be easier? All right, let's make it freaking 30 then, because I got 87. So obviously I have what the 29 needs. I need you to see this. We're going to combine the shit. It's a pile of $87 and a pile of $29. Couldn't I take $1 bill from that pile and put it in that pile? Magic. So this is compensation. So how would I rewrite 87? 86 plus 1, just to show all the steps, right? Now in your head, you don't have to do this step. But when you are showing this to students, you want them to see, okay, this is 87. I didn't change the problem, but now this is 30. Jeff, 86 better. And then when I do 8 plus 3 is 11, and then 6 plus 0 is 6. So 116. We got 116 again. Thank the gods. You guys get that? I might hold you to no compensation. But in the grand scheme of things, I am less worried if you know the word. I am more worried if you know how to do it. Yes? You don't have to use the word compensation when you show your students this method. But you know it's officially called compensation, right? I want my teachers to know what the hell they're doing, even if you don't use the word with the kids. But if you at least know how to do it and how to show somebody else, that's what matters. Does anyone see a last way to do this? Think the other way. This way we just did was we took something from 87 to make 29 a better number. But I take something from 29 to make 87 a better number. What would I take from 29 to make 87 a better number? What does 87 need to become the best number possible here? 13, yes? If I give him 13, what's he become? 100. And adding anything to 100 kicks ass. Yes? So if I do 87 plus 13 plus what? 16. 87 and 13 is 100. 100 plus 16 is 116. Yay! Okay, cool. All right. You guys with me? Does anyone ever used any of these things we talk about ever in your own life? If you ever worked as a waitress, if you ever worked in a store, if you ever worked where there's numbers all over the damn place, you must have done something like this. Now back in the day, waiters and waitresses in my class, they would know how to calculate a tip. Because very few receipts came with the tip on there. And nowadays I think almost all receipts come with the tip on there, yes? No? Maybe? Who knows? I don't know. Everywhere I've gone out to eat, it's been like that. So, I might be one of the few people that cries when I see them not really cry. But that's one of the few places people got practice with math. That and change. What happens nowadays for change? It just plops out of this change machine, right? You guys with me? Which is good because people would make mistakes and you would get the wrong amount of change back. But it's bad because that was one place people got to practice their numbers. Yes? We all have to be better with numbers. Okay. All right. Whatever, math boy. All right. Something else we talked about before. Yeah, I'm sort of in this. Yeah, we'll keep going. Oh, here's one new thing we haven't talked about before. What if I had to do 784 divided by 7? And I want you to do that in your head. Yes? I'm looking around for everybody's reaction. Some of you guys are like, try to make me do that. Now here's the weird thing. There's a weird ability of division. There's a distribution property of division. Can you guys, if I had 10 plus 5 divided by 5. Now I could just make this 15 divided by 5 is 3, yes? But do you guys all understand what is being divided by 5 right now? The way it's written, what's being divided by 5? 10 and 5. So there's actually kind of a distributive property of division. What's 10 divided by 5? 2. What's 5 divided by 5? 1. So you get 3. Now with 10 plus 5 over 2, why the shit over 5? Why would we ever do that? Because I could just make it 15 divided by 5. But with this crazy ass number, what number is 74 really close to that 7 goes into really easy? Like, okay, if I said, does 6 go into 66? Why is that like a dumb question? Does 6 go into 66? Why is that kind of a dumb question? Because 66 is 2 6's, dude. So of course 6 goes into it. Does 8 go into 88? Like, yeah, they're both 8s. You with me? So 7 goes into the same way. 7 goes into 77. So isn't 784 770 plus what? Rewrite 784, 770 plus 14. And now if I do this kind of new distribution deal, this is 770 divided by 7 plus 14 divided by 7. What is 770 divided by 7? Yeah, 110. 14 divided by 7. Okay. Do you guys follow the logic? By the way, even if you don't right now see the utility in this, you want to become an elementary teacher. Do you want your students to be able to do this? Can you imagine if everybody was able to do this? Man, I sit down and imagine this all the time. This world would be much different. People would be much more able to verify claims made. You have no idea how many times I've heard people talk about really important ideas, and they just slip in all these miscalculations and mislead people. I'm like, holy shit, if only people knew math, they know this guy's full of shit. People don't know math, and they just say this shit, and people go, ah! Alright, sorry, I'll be right. Or even just on a basic level of like getting gypped at a store when they have a discount, and they misapply it, and every time they misapply it, it's in their favor. Interesting. But not enough people know to check it, so they get away with it more often than not. Okay. Has anyone ever heard of that? That's a little weird. This should kind of freak out a little bit, that you can distribute division, and it's just because I can rewrite this as 10 over 5 plus 5 over 5. So it does distribute to both pieces. Only if it's on that side, though. It's got to be on the right side. This is called right distributivity. Did I spell that right? Who knows? Of division. Right, distributivity. Too many distributivity of division. It's okay if you've never heard of that because it's something we sort of gloss over, but it's a good thing to know. It's useful. Okay. Blah, 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 blah. So let's see, we already talked about that. Oh, what about this? I'm pretty sure I talked about this already too. I don't know if anybody remembers what this reference is. Equal additions. Remember we talked about like 100 minus 21 is the same answer as 99 minus 20. Which problem is easier to do in your head? 99 minus 20, yes? That's equal additions. What they really should say is equal movements, because in that case we subtracted, yes? So for example, if I had to do, here's one example. If I had to do, what you got, Jeff? You could do it, Jeff. 71 minus 29. So let's use the name directly here. What do I wish I was subtracting? Subtracting 29 sucks. I wish I subtracted 30. Now, if I make that part go up by 1, I want to keep the distance the same. So if I make this number get closer to him, how do I make the distance the same? I make this number get closer to him. I got to make this number, I don't know if you guys are with me. Y'all agree that 29, let's say 29 is here, and 71 is here, yes? I just made 29 become 30. Is that the same distance it was? So what I better do is freaking 71. Make it become 72. That's why it's called equal additions. And what did I add to 29? 1. So what do I add to 71? 1. Equal additions. So if I add the same thing to both, and you could add a negative, so that's why I think we should call it equal movements. If I move one by one, I got to move the other one by one. Then the distance is the same. I need you to be with me. Subtraction, subtraction fundamentally means distance between. So if I move one of the numbers involved in a subtraction problem, different distance. If I move the other number the same amount, same answer. That kicks so much ass. I can do shit like get whole numbers where I want them to show up. Yes? That by itself is like a beautiful thing for every human to know. All the humans. So this should become 72. And what's 72 minus 30? 42. Sweet. That's the answer to everything. Okay, we have talked about that before. Just very quickly, I think I brought it up. But now it's a part of what you're going to see in your homework is this equal additions idea. Let me think. All right, I'm going to show you something that is definitely way too early in terms of this class, but I know you guys all know decimals exist. So I'm just going to show you this. It's not going to be on a quiz or a test or anything because decimals are not for a little while. But what if I had to do 1 minus 0.9173? Are y'all excited about that? Do you understand what would be involved if I had to do this by hand? What would be involved in the subtraction? A lot of what? Uh-oh, shit. A lot of borrowing, yes? But if I make this one go down by 1, what do I make this one do? Go down by 1. 0, 8, 2, 7. Easy shit, yes? Easy shit. Real quick, here's the ultimate. Is everybody semi-decent with that? I know I brought decimals in. You all know decimals exist. You're not actually in 5th grade or 2nd grade or whatever. This is how it will work with decimals. The same way it works with whole numbers. However you move one, you got to move the other one the same amount. But now watch this. Look at this number. What do you add to this to make it 9? I know it's a weird question. What do you add to this to make it 9? 0. You with me? You with me? What do you add to this to make it 9? 8. What do you add to this to make it 9? 2. What do you add to this to make it 9? I'm sorry. What do you add to the last one to make it 10? 7. So 0, 8, 2, 7, right? Now, do you currently have to know everything I just did? No. But when I teach like statistics, has anybody taken stats? I think I've asked you this once before. If you did stats and you did probability, didn't you have to do like 100% minus something? You have to do 1 minus all these weird things. So then you could just go, make that 9, 0, make that 9, 8, make that 9, 2, make that 10, 7. Done. Quicker than the goddamn calculator, right? I'm still typing it in. You're like, you're done. Shit. Anyway, sorry. You don't have to currently know that. It's just directly related to the idea. Let me see what else. Oh, what about this? We can have multiplicative compensation. And you're all like, we should get paid just watching you write, Jeff. You're horrible. Whatever. You are. Multiplicative compensation. So the idea of compensation doesn't give a shit what the operation is. It says you're going to take a little bit from one guy, give it to the other guy, and go to town, right? So for example, if I had to do, did you give yourself a problem? Not really, Jeff. Good job. 142 times 5. Don't you wish this was a 10? Y'all agree if that was a 10, this problem would be stupid easy? Just add a 0, yes? Is this even? Is there a factor of 2 in it then? Okay, so how can I rewrite 142? What times 2? What times 2 is 142? 71. Yes. And what's 2 times 5? 10. And what's 71 times 10? 710. Yeah, sweet. So that is compensation because you took, so in this case, it's multiplication. So we took a factor from one and gave it to the other one to make it an easier problem. Same answer, because it's got all the same parts in it. I just reorganized the parts. Has anyone ever done that? You know, you can do that anytime you multiply by 5. Basically, the real shortcut is you divide what you got by 2, and then you move the decimal over once. Because that's what happens when you multiply by 10. You guys you multiply the decimal one. So 142 times 5, cut 1 and 42 in half is 71. Move the decimal over 1, 710. Okay. Was that your only example, Jeff? Sure. Yeah, we have more coming up later. So that's basically multiplicative compensation. Another one could be something like, here, I'll do one more example. 88 times 25. Obviously, you can't really apply this trick easily unless, like on number 1, the 142 had to be even. So I could take a factor of 2 away, nice. In this case, what factor do I want to take away from what? What number can I change into a better number? How would I change 88? So here's the problem. Somebody agree with me this is a multiplication problem. I can't take 12 from 25 and add it to 88 because the problem is not an addition problem, it's a multiplication. So when I'm doing additive compensation, I could subtract from one and add to the other one because it jives with the operation I'm doing. If it's multiplication I'm doing, I have to divide from one and give it to the other one. So everybody still falls into the purview of multiplication. Does that make any sense? So like, if I write 25 as 12 plus 13, I can't add these together because it's multiplication. I'd have to distribute, which I've just made it like worse, right? Okay, and nothing wrong with what you suggested, just that's a weird thing to realize. So what factor of 88 do I want to take away so I can give it to him? 4. So what's 88? What times 4? 22, yeah. 4 times 25 is? 100. And then 22 times 100 is? 100. Okay. I love you guys. You're all like, good Lord, Jeff. I play your videos at night so I can go to sleep. So everybody okay? So, do the same thing. Oh, no. What's up, these poor kids? I write horribly and I form. Now, so that idea is compensation is independent of, well, it works for addition, it works for multiplication. Equal additions is sort of related to this, but we just look at it as, I just look at it as moving each number the same amount. Okay. Blah blah blah, blah blah blah. What about? All right, just these. Some of these are kind of silly. Powers of 10. Powers of 10 kick ass. Does anyone know the quick way to multiply this? What's the quick way to multiply that? Yeah, 2 times 3 is 6. Okay, I'll take your word for it. And then, where do I go from there? Yeah, how many total zeros to go? 3, 6, 9, 10, yes? So I need 10 zeros, because there's actually 10 factors of 10 up there. There's 6 factors of 10 with the 2. There's 5 factors, what did I just say? 3, 6, oh, there's 11 factors. There's 6 with the 2, and there's 5 with the 3. So I have 11 zeros afterwards. So I can just go 3, 6, 7, 10 zeros. I still didn't say it right. 4 here. So this will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You bet. What number is this, by the way? Yes, so it's 1,000, million, billion. If I put another set of 3, that would be trillion, and now we're talking about the debt of the U.S. Yay! Go team. Okay. We're the best. Oh, and then, okay. This is a little quick, but these are little tiny things. We have something called special factors, and I've already used some of them. 5 is a special factor, 25 is a special factor. They're kind of related to compensation. 99 is a special factor. When I multiply something by 99, I am almost multiplying it by 100. And of course, multiplying by 100 kicks major acts, because I just add 2 zeros. Remove the decimal twice, and I have a decimal. Okay. How does 99 relate to 100? Weird question, but I mean, what do you do to 100 to make it become 99? Subtract. So when I'm multiplying by 99, so somebody give me a number. Any number. Any number. Could be really big, could be really small, could be whatever.
72.
Huh?
72.
72, thank you. And I'm multiplying by 99. Yes? I like somebody over there who's like, just tell them a number. Replace 99 with 100 minus 1. Yes? Now, let me ask you this real quick. When I look at that problem, I say to myself, oh, I've got 99 72s. That's what that means, because that's what multiplication means. Doesn't mean I have 9. Now, that specifically would mean 72 99s, but we know commutative. So I turn it around and go, okay, I got 99 72s. That's 172s minus 172. Yes? So you don't even have to do what I'm about to do. You don't have to think about it this way. You can think about what we just said, but isn't it 72 times 100 minus 1? Which is 72 times 100 minus 72 times 1. Which is, yeah, about 71.99 minus 71 if I wanted to, which is 71.28. Wow. So I can use several equal additions over there also. But I think some of you guys, most of you guys should know 100 minus 72 is 28. So 200 minus 72 is 120. So you can combine these mental mathematical tricks, strategies in one problem. How you guys doing? Good job. So like 98, I would argue, is also special, because then I would just do 100 of them minus 2 of them. So if I had 98 times 72, I do 7,200 minus 144, 2 72s. Maybe. Yeah, I think I'll do, okay, let's do this. Okay. I'm gonna shut up, and what I want us to do, I have created a worksheet that I want you to, I know, it's amazing, I never do worksheets. I want you guys to do these 4 problems. There. So last thing, the next part of this gets a little bit tricky, and this is actually something we saw in the video. This is called the left to right method. So I was going to do 342 plus 136. So left to right. When we add, we normally line them up and we add right to left. If you think about it in your head, you add right to left and you carry ones when you need to, correct? So left to right just means, just start adding left to right. So I got like 300 plus 100. Just like what the little dude did when he did 28 plus 35. So I would do 300 plus 100 plus 40 plus 30 plus 2 plus 6. So you get 400 plus 60 plus 8, 468. 70, Jeff. That's awesome. I need to sit down and have somebody come closer to me. Okay. So left to right method, that one's nice because there was no carrying of stuff, but you don't have to carry when you do it this way. So for example, if I did, what do you got, Jeff? 489 plus 372. Can you guys set it up? What would that look like, left to right method? So you literally go left to right. You take the hundreds and you just combine them directly. You take the tens, 80 and 70, and you take the ones, 9 and 2. 700 plus 150 plus 11. So there's no explicit carrying of a 1, right? But do you see how carrying a 1 comes out naturally this way? If you line those numbers up, you get 700 plus 150 plus 11. This came from the things that were in the middle, but this 1 carried over to the next place, yes? There's a lot of ways. And in fact, what you end up doing is you do all the ways and then you bring it all together. There's a lot of ways to show physically, in this case this is more computationally, how that carrying of the 1 happens. And obviously with the 11, there's another carrying of the 1. Because it was in the 1's place, it bled over into the 10's place because it became 11, so that 1 carries to the next place. Okay, maybe. And then at the end you get what? And 1 more? Okay. I love that. Video is awesome. Where'd it go? Oh, yeah. I think we talked a little bit about that. I might have skipped over this, actually. I think I skipped over this one for some reason. What about 4 times 256? How would you do that with the left to right method? Oh, yeah, I did skip over this. So this is multiplication. So we're going to do it left to right method. What do you think would be involved there? What are you multiplying 4 by? Piece by piece. Yeah, 4 times 200 and 4 times 50 and 4 times 6. 800 plus 200 plus 24. And what's that? What's that? Yeah, 1,024. Now that's pretty nifty. And to be honest, especially for that problem, that's actually better than lining the damn thing up like we normally do, yeah? Okay. Maybe. Oh, okay. This is perfect. We have no idea what you're talking about, Jeff. I understand. That basically is 4.1. That's 4.1. I'm going to talk just a little bit about 4.2. 4.2 is where we start to develop the way we're going to evolve into like the carry the 1 algorithm. By the way, what's the word algorithm mean? When I say algorithm, what do you guys think? Could be anything. You could say, I think about my Uncle Tom, because he always talked about his name algorithm. What do you think when I say that? Does anyone think anything? Has everybody heard the word algorithm before? Okay. What do you think when I say that? Anybody think anything? Or are you like blank slate? Yes?
A way of doing something?
Say it.
A way of doing something?
A way of doing something, kick ass. That's a kick ass definition. Has anybody ever made something based on a recipe? That's an algorithm. Has anybody, do you guys know, anybody ever done any computer programming? Or even like website stuff? No, you can like screw that shit. But you know computer programs. You can run them and they do stuff like that. So that would be a very obvious algorithm. So all an algorithm is, it's like a recipe. Jeff, what are you doing there, buddy? Did you put too many H's in there? You did. Okay, I need it now. It's a systematic way. Let me get this exactly. Step-by-step procedure. Produce, Jeff, really? Okay. Procedure. Oh, that's it. And then I have like recipes, computer program, blah, 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 blah. Okay. Systematic step-by-step procedure. So algorithm doesn't have to be something mathematical. Normally when I say algorithm, people think math or they think computer science. So what we're about to get into is if I was gonna do something like 78 plus 35, we want to start with the visual thing, the physical manipulation, and then get to the point where we can have the algorithm, the standard algorithm. All right, so if I said do that, you guys would all put a 3, carry the 1, right, and then add and get 100 or 2. Yes? Almost certain. Because we all know the standard algorithm. So there's a lot of steps to get to that point. And one of the most basic steps, and this will be the last thing I do today. Do you guys remember the base 10 pieces? So like this means 100, this means 10, this means 1, yes? Just to draw them very quickly. You guys all with me? So the flat, the long, and the unit. Okay, so next time I'll actually let you play with some of these base 10 pieces. So if I do 78 plus 35, how would I represent 78? What would I put down here? Yes? 7 longs, right? 1, 2, 3, 4, 5, 6, 7, and 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. There's 78. 35, of course, would be 3 longs, 5 ones. So if I add those together, which we've done before, I had you guys do this kind of thing with base 3 pieces. Just put them all into a big pile, and you end up with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of these. And you end up with 8 and 4. You end up with 1, 2, 3, 4. Why did I put 4 there? Good job. 5, 6, 7, 8, 9, 10, 11, 12, and then 13. So how many units become a long? 10 of them. So if I count 10 of these off, you can do it, Jeff. Can you? Yeah, I think this is 10. Yes. Those become one of these. And then how many longs do I need to become one flat? That's crazy. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these 10 become a flat. And then I got this 1 here, and then I got these 3 here. So that's 113, which is what it's supposed to be, right? Do you guys see? Okay. Next time I'll actually take them out to base 10 pieces, but that would be a visual thing. They're just playing with pieces. But you guys see how the carry the 1 is in there. It's just not explicit yet. Because they have to see examples of it happening to buy into it. And then you could say, now we got a shortcut for this. Okay, maybe. All right, I want to let us out a little early today. I want to let me out a little early today. So you guys get to enjoy that. It's good to be the teacher. I think that's enough for class. Yeah. All right, guys. Let me know if you have any questions. Otherwise, I'll see y'all Thursday. We'll talk about the next quiz on Thursday. Yes.